Today we are discussing about difference between open and closed circuit. Yesterday we are learning about the electric circuit. In electric circuit, some components are interconnection between the plug key, bulb, and cell. And that cell means it's like a battery. So we have to produce a from positive charge to negative charge. Current can be formed. That means electric current. So we should learn about the electric current, electric circuit. Now here, the difference between open and closed circuit means, see, open circuit, plug is taken out from the plug key to make the circuit diagram. So plug is taken out from the plug key. Yesterday I said that one plug key, the two brackets and one dot symbol is there. So that is the plug key. Whether the point is not there means plug key is taken out from the plug. If point is will be there, the plug is inserted the key. So here closed circuit, the plug is inserted in the key to make the closed circuit. So there is a difference, the first difference of open circuit and closed circuit. So plug is taken out from the plug key and plug is inserted in the key. Now this is the second point. No electric current flows through the electric circuit. That means when the positive charge to electric charge, the electric charge is formed through the line. When it is plug is open, that means plug is taken out. So no charge can be formed. There is no interconnection between positive and negative charge. So that's why no electric current flows through the electric circuit. See the second one, the closed circuit. Continuous current flow through the circuit. So why continuous current flow through the circuit means when the plug is inserted, then the current can be flow through the circuit continuously. So that's why this is the second difference point between open circuit and closed circuit. Now see the circuit diagrams of open circuit. So this is the open circuit diagram. So in this open circuit diagram, we have to see here, this is the cell and this is the plug key. So plug key means here not a point. Here not a point means there is a open plug key, and this is ammeter and this is resistance and that is bulb. So the current flows through this direction. See these arrow marks. So the entire arrow mark means the current flows, that means the charge flows on the from positive cell to negative cell. So this is can be open circuit. Why it is open circuit means they have a no plug. So that's why this is open circuit. Now see the closed circuit diagram. See in closed circuit diagram same as well as bulb, resistance, ammeter and cell, but there is a point will be there in the brackets. So in the point means the plug key is inserted. So that's why the circuit diagram is closed circuit diagram. Now the current flow of direction means the from positive charge to negative charge. So the when it is the point is here, when it is the point is here, the continuously current flows through this circuit. So that's why it is called a closed circuit diagram. So this is two differences between circuit diagrams, open circuit diagram and closed circuit diagram. See now static electricity, STATIC static electricity. Static electricity means, yesterday we learned about the electric current, that means the charges flow of electric circuit. Now here electricity from the static, that means it is an imbalance of electric charges within or on the surface, and that means the charges within the surface or on the surface of the material. So which have material is inbuilt on the circuit, so that material can be have the charge carries is within the charge or within. Now the charge remains until it is able to away by means of electricity. So the charge is at rest. So what is here? The charge is at rest. So when the charge is at rest means that is a static electricity. When the charge is moves means the electricity charges can be flows through the circuit. So that's why when the charge is at rest means the electricity charges could not be moved. It should not be moved. That means it should not be motion. So that's why the charge is at rest of the electric current is called static electricity. It is also known as electrical discharge. That means we are the free of electrons. Free of electrons. That means the free of electron means the charges cannot be moved on the circuit. You understand? See, electric potential and potential difference. So there is no difference between electric potential and potential difference because of electric potential. How much electrical charges can be applying on that circuit, either positive or negative charges. See the definition of electric potential. Electric potential at any point in the electric field is the work done in carrying unit positive charge from infinity to that point against the electrostatic force of the field. That means electric field. It is denoted by capital V. So here in electric field some work done is be carrying a positive charge. So here work done means there should be some energy can be utilized. Some energy is used. That means the electrical energy used in carrying a unit positive charge from that a point or infinity. So that's why here we can get through a electric potential. So certain force, electrostatic force. Electrostatic force is nothing but all the electrons should be moving. That means the electric charges from move entire the circuit. So that's why here the electric field, that means electrical energy which is carrying on that circuit, that is called electric field. So that's why, so electric potential is denoted by V. So V is equals to W by Q. Here W is equals to work done, Q is also known as electric charge. So V is equals to W by Q. Right, see the potential difference. Potential difference make a between 2 points. So that means the electric field charges between 2 points, how much potential, how much carrying the electrical energy between the 2 points. We should know about the potential difference. So here the definition of the potential difference is the electric potential difference between the 2 points in an electric circuit carrying some current as the work done to move a unit positive charge from one point to the other. So it is also denoted by V. Therefore, the potential difference between 2 points A and B is VA and VB. That is delta V is equals to VB minus VA. So here in between 2 points there is A and B. So if suppose the electric charge, that means the electric current carrying by A and the electric current carrying by B. In between 2 points the charge difference, that means the electric potential difference between 2 points is VB minus VA or VA minus VB. So whatever it is. So here the potential difference between 2 points such as the current carrying by the work done to move a unit positive charge. So that's why we can go for the potential difference between 2 points. Therefore V is equals to WAB by Q. Here W suffix AB means the work done at A and work done at B. So that's why WAB by Q. Therefore V is equals to WAB by Q. The SI unit of electric potential difference is volt. So volt is one of the scientists. He is an Italian. So that's why his name can be used as a unit of electric potential. So 1 volt is equals to 1 joule by 1 coulomb. How could we get 1 joule by 1 coulomb? That means V is equals to W by Q. W means work done. That means energy can be units are joules. That means work done units are joules. And Q means charge. The charge unit is coulomb. So that's why 1 volt is equals to 1 joule by 1 coulomb. Here 1 V is equals to 1 J C minus 1. That means C power minus 1. That means the coulomb can be changes to numerator. Therefore 1 joule per coulomb. That means 1 volt is equals to 1 joule per coulomb. The electric potential is a scalar quantity. Why it is scalar quantity? because of voltage is a, that means electric potential is a, they have a no direction, they have a no direction, so only magnitude, so that's why it can be called as a scalar quantity. So the potential difference is measured by means of an instrument called voltmeter, that means VOLTMETER, voltmeter, that means which is carrying by the voltage in the circuit. So we can observe in that instrument name called by the voltmeter. So that's why the potential difference is measured by means of an instrument called the voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured. So that means the voltmeter is connected between 2 points across the parallel only. So that's why the voltmeter is always connected the parallel. So we can find the potential difference between, in that voltmeter we can measure the potential. See some examples here.